So 100 milliliters of 5-alcohol solution mixing with 2% alcohol solution with 7% alcohol solution. So we're looking to make 100 milliliters at 5%. So we want to be able to set this up. Hold on. Oh. Let's try this one more time. I don't know why it's all wacky on me. Let's try this again. John wants to make, so we have our two solutions, right? We have solution 1, solution 2, and we have our final solution. He wants to make a 5% solution of 100 milliliters of water or whatever. The first solution is at 2%. The other one is at 7%. We're going to add these two together. Let's just let the solution of first one be x. Then whatever's remaining after we take out x, so it's going to be 100 minus x. Is that what you guys got too? Okay. When we write this out, we're going to write our solutions as 0.02x, it's 2%, plus 0.07 times the quantity 100 minus 0.0, or we'll just do this, minus x is equal to 0.05 times 100. Distributing out and reducing, we get plus 7 minus 0.07x is equal to 5, right? Combine like terms, I'm going to get negative 0.5x. Bringing that 7 over to the other side, I'm going to get negative 2. Dividing out, we should get x is equal to 4, right? 40. Moving it over twice. So it tells me my first solution, or at least x, my first solution is going to be 40 milliliters at 2% alcohol. If we plug it into this other equation right here, 100 minus 40 is going to give me what? 60% alcohol at 7%. I'm going to give you guys the answers to the homework, so check it out. We're going to come back and look at more of these word problems next week. I want to be able to kind of set it up a little bit easier for you guys, so I'm going to wait until next week to kind of teach you it, giving you a better understanding of word problems. There's two that I got to go over, and I want to spend more time on those, so I'd rather not have a 3-day weekend and worry about it than to try to come back and reteach you guys what we learned. So as long as we're able to kind of do the beginning of these, I'm okay with the first set. We're going to move on and come back to it next week. I would just copy down those answers if you want to try those out for a little bit later. I know I did not give you them all, but they're good problems to go over. My first period, I was kind of wacky with them, so I'm going to switch out the problems for these. I was going to give you guys, I'll probably put it as an extra credit problem. So I'll leave a problem like this on there for you guys if you choose to do it. So be aware of it. Either that or I'll put multiple choice on it as well. So that might be something I can do. Any questions on the homework problems I did for you? Yes.
Just question for two. Like, this is at 90. What is that after the 90? But I was at 91.
At 90% concentration.
Okay.
Yeah. Yeah. No, at 90% concentration. I need to change around those pure kind of questions because they just are wacky. For 3 and 4, we're kind of really off, so I'm not going to worry about those. Okay. Do me a favor and take out your notes. There you go. So we're going to kind of move back. Again, we're going to kind of look back at the word problems next week. I'd rather have more time and kind of going back and forth with this. This is not a difficult subject to talk about, so we're going to kind of move on from there. We're going to look at inequality, specifically both linear, quadratic, and absolute value. We're only going to get up to quadratic today. We're just going to practice this as best we can. Give you guys some problems to work out. If you guys are good, we'll have the homework tomorrow. It should consist of about 5 to 6 questions. I'm almost halfway done with it. I'm going to ask you specifically to solve by completing the square is one of them. Solve by factoring is one of them. Solve by quadratic is one of them. I'm going to throw an inequality type problem in there, probably 2 of them. And I'll probably just for an extra credit throw in a solution mixture type of problem. So I'm going to kind of keep it simple. Maybe look at the old review kind of materials, solving equations, creating a common denominator would be a good one to throw in. So those are the only ones I'm going to look at. Maybe solving a simple quadratic, nothing too crazy. So keep that in mind. Okay, here we go. Went over the quiz. We're having one tomorrow. We're going to kind of review that. Don't worry about that. Here we go. Solving inequality. To solve an inequality that contains a variable means to find all values of the variable that make the inequality true. So a lot of the times that we're going to be doing this, we're not going to be able to look at just one solution. Unlike an equation, an inequality generally has infinitely many solutions, so depending on what number we can plug in. It also means that we can form an interval or a union of intervals on a number line. That means we can both graph it and show it as an interval notation, just like 1.1 did. So we're going to relook at that material. We're going to review these fairly quickly, and then we're going to kind of dive into the more trickier stuff. It's not that hard today. It's not going to be that hard. We're just going to practice some more problems. Mm-hmm.
When it says these, that means that the solutions, right? Like these form, those are solutions.
What's your question? What's your
I just
question?
answered my own question.
Okay. Okay, here we go. The other thing we also want to be able to notice as well is if you multiply or divide by an inequality by a negative number, we flip the sign. The sign gets flipped. So we're going to look at just these two examples. So I'm trying to get my wife to send me some more stuff. If we're multiplying or dividing by a negative, we definitely want to be able to say that we can switch the signs. So it's going to do this for me. Just reset it and forget it. Sorry. Let's try this again. If you'll do it for me, come on, man. Okay. The good thing about looking at these is we always want to have the variable on the left-hand side unless it's compounded, meaning we have two of them. If we divide both sides by -1, we could simplify these out simply. The only difference is coming from the inequality that changes. So it becomes greater than or equal to, becomes less than or equal to. If you want to look at it as multiplying, you can multiply both sides by -1. But if you're multiplying or dividing by negative, it will change the sign. So this will still be x. This will still be -2. And less than now becomes greater than. So just keep that in mind as we kind of go along and do these problems. It will switch everything around. So it's important that we're able to kind of see those. Okay. Okay, here we go. The next thing that is important for us is looking at just simple problems like this. So let's look at these two different types. We have one that's a single inequality and one that's a compound inequality. It's always easiest, and I'm going to put this as a subnote, it's always easy to put, let's put an asterisk over the top of this one. Put x values to left side. It's easier to see the inequality that way and you won't get it mixed up. But if you understand inequalities and it makes sense to you, do whatever way works for you. I think it's easier just to bring everything to the left-hand side. We have one single inequality, which is 3x less than 9x plus 4. And then we have a compounded. 4x is less than 3x minus 2, less than 13. So the way that these two work are completely different. And I'm going to show you what they both look like when we're going to graph them. Solving out for A, I'm going to go ahead and just bring all my x's to one side. So I'm going to subtract out 9x to both sides. And we're solving these just as we would any other equation. So these are not any different. Okay. We're going to get negative 6x is less than 4. And then to solve this out, what should I do? Divide by negative 6. Since I'm dividing by a negative, what happens to my sign? Flips. So my final solution will be x is greater than negative 2/3. Now we want to be able to show both. I want you guys to get used to showing both the graphical representation and the interval notation for this. Okay? Doesn't need to be perfect unless I give you whole numbers, and you should be able to give me whole numbers for this. For the graph portion of this, let's say I have my number line here in both directions, and let's say this is 0 and this is negative 2/3. Is that at 2/3 going to be open or closed? Open. We definitely did these before in 1.1. This is the first week we did it on. In whatever direction, because the x is on the left-hand side, we can actually put the arrow in the direction of the inequality. Okay, so it's going right, so my arrow should be going right. Okay. If the x was on the other side, it would be going the opposite way. This is why it's always easy to put it on the left-hand side. Okay, that is the graphical representation of this inequality. On the interval, if you've already graphed it, the interval looks very easy. All we're going to get from this, open bracket or open parentheses, because we have a greater than, not strictly greater than or equal to. Says it's going to the right. This is our interval. Interval. Yes. Yes, all three of them. On tomorrow's quiz, if I put something on here, I'm going to ask you for both the interval and the graph and your solution. So you'll have to give me all three of them. Okay. So we have our inequality here. We have our graph representation of it. And we have the interval notation of it. Should be able to give me all three. With the compound inequality, slightly different. In this case, because we have two inequalities, that being strictly less than or equal to and less than, we're actually going to solve this on both sides. So whatever we do in the middle, and I'll kind of rewrite these. Whatever we do in the middle, or to solve out for x, we're going to solve to both sides. So to solve for x, let's go ahead and add 2 everywhere. We're going to add 2 to each part of these inequalities. Did you guys do this last year? No? So this is brand new for a lot of you? Okay. Just like solving. Just like solving. Think of it like 2 equal signs. You're just solving it on all parts. Okay, and it will look very nice. 4 plus 2 is going to be 6. We're still going to get our 3x in the middle. And we can write these inequalities in here as we're going down. 15. And then we're still going to solve this out one last time by dividing out by 3. So we can still solve this out by dividing out by 3 everywhere. Whenever we get a compound inequality, which is 2 inequalities in one problem, we got to do it everywhere. So 6 divided by 3 is 2, less than or equal to, our 3's cancel out, giving me x, which is strictly less than 15 divided by 3, 5. So this is going to be my solution for this. And again, if our x exists between 2 numbers, it's existing in between these intervals. So our graph representation of it will look like, let's say this is 0, 1, 2, 3, 4, 5. So 2 and 5. We have a closed circle at 2. Closed circle at 2. an open circle at 5, and we're just going to connect the inner terms of them. We're always going to look at the inner terms for a compound inequality. This is our second solution. And our interval is going to go close bracket to 2, open bracket at 5. Done. So we'll do more of these. We'll do more of them. Don't worry if you haven't done any of these. We'll definitely practice these. We'll definitely practice these. Okay. Should have reviewed these already. I believe you guys should have, but I haven't taught integrated 3 in a while. So if we need to practice like we never did it, we're fine with doing that. Okay. Yes. Inequality? On this side? Why did I switch the sign, guys? Divided by a negative. If we're dividing or multiplying by a negative, it changes the signs. That's the only time it does it. It's the only time I do it. Only time it does it, not it. Or does it. It does it. You're good. Okay? So don't freak out. Okay? So those are going to be key. We're going to look at those. We'll look at solving them. We'll look at practice solving them. We're going to look at quadratics as well. Okay? Here's the next part to this. So we're going to look at solving all these different types, and then we're going to come back and solve them. Okay, solve solutions to quadratic instead of giving you this big old type of thing where it can be confusing, I'm going to give you just how to solve it. If you're going to pursue math in the future, let me know. I'll be more than happy to show you why it works that way. Okay, but it depends on what type of symbol we have in our solution. The best thing about this is we're still going to bring all of our variables to the left-hand side. We're going to factor the solution. And we're going to use the inequalities to determine how the solution is written. Meaning what is true for the solution and what is not true. And depending on how we write that, depends on what you want to be able to write for these. Okay, and we'll kind of go over that. So we're still going to bring everything to the left-hand side and we're going to factor it. Yes? Everything. We're gonna set everything equal to the right on 0 on the right side. We're gonna bring everything to the left-hand side. So we're still gonna be able to solve this out. Okay. Okay. We're going to come up with 2 examples just to show you the basic things of what the solutions are going to look like. We still got to be able to graph the intervals. We still got to be able to graph the graph on the number line. If the symbols that are provided give you less than or equal to, less than or equal to, okay, here's how we're going to do it. Let's say I give you an example where we get a solution x plus a and a factor of x minus b is strictly less than or equal to 0. We brought everything to the left-hand side. We already factored it. That's done. Okay. If the less than symbol is there, less than or equal to symbol, my solutions are still going to be the same thing, and we're going to kind of discuss this. My solution will be negative x or negative a and positive b, where negative is less than, or a is less than b. Now, hey, listen. Yeah. Okay. On our interval, if it's strictly less than, let's look at how the solution will be graphed. The graph solution of this is going to look the following. Let's say this is negative a this is B. Because we have strictly less than, we're going to have closed circles on negative A and B. And because it's less than, we're actually going to be looking at the values inside of these. So they're going to be connected. I'm going to kind of write that these are connected. On the interval itself, it's going to go from negative A, comma B. So because the way we've been looking at these, we're bringing everything to the left-hand side. If you're solving these out and we strictly give you less than or equal to, we're going to be putting them on a number line, and it's going to be on the inside value. We're having only one interval for this notation. Okay, let's look at the opposite idea. Okay, we're used to that. We're used to seeing something like that. We did many of those. If the symbol is greater than or equal to, meaning it's the other way around, it's going the other direction. Let's come up with the same idea. Let's say x plus A, x minus B is strictly greater than, so we're going to say greater than 0 for this one. The solution to this is going to look a little bit differently. We're still going to get the same values. X is equal to negative A and B, where negative A is definitely still less than B. On the number line, it's still going to look the same. So we're going to have negative A and B. Let's say this is 0 here, 0 here. Okay. Now, in the terms of our solutions, we're going to have an open circle because our inequality is not greater than or equal to. This time, because the greater than symbol, we're actually going to go not connected, but we're going to go in the opposite direction. Our solution is everywhere but the inside of this. So it's negative infinity from negative A to negative infinity into B to positive infinity. So that is if we have a greater than or equal to symbol. If it's strictly less than or equal to, it's going to be on the inside. Okay. So the interval looks quite different as well. On the interval, it's going to be negative infinity, comma negative A, and the solution would be from B, comma positive infinity. So depending on that inequality, you're solving out the same way. It just depends on your inequality, whether it's less than or greater than. You got to know the difference. Okay, you definitely want to be able to see the difference with that. Okay. And let's just look at some of these problems. Let's just try to jump into these type of problems so you can see the difference of what we're doing. Okay. So now we're going to do some examples for you guys. Okay. Cool beans? Does this make sense at all so far? No? No? Let's just look at it. Remember this page. So highlight those if you need to. Look at them. Okay. Here we go. Let's look at this example. Solve the inequality. And just so we have our reference, let me see if I have this. Let's see. We're going to be graphing this solution. So you're going to be given a number line. Let's say this is 0. And let's do, this is our graph. And this is our interval. Okay. Whatever the interval happens to be. This is for quadratics. This is for the quadratics. So let's look at these different types. Now, let's solve it out just as we regularly would. We're going to bring everything to the left-hand side. All of our x's and all of our terms are already to the left. Let's solve this out. Can we factor it? What are our two factors? X would be negative 2, and x would be negative 3. Strictly less than or equal to 0. What would be my solutions? What would x be can be equal to? 2 and 3. We always do the opposite of the factors, right? 2 and 3. So this is technically my solution. This is technically my solution. I have my values here. So let's go ahead on my number line and graph these in. Let's go 1, 2, 3. And let's make it bigger just so you guys can see it. 1, 2, 3. So this is going to be 1, 2, and 3. Okay. Now, so we graph the interval, we have our solution. Let's look at the inequality. It's strictly less than or equal to. It's strictly less than or equal to. So just before we even do it, do we have an open or closed circles? Closed, definitely closed. So at 2 and 3, we definitely have closed circles because of the inequality. Okay. Now look at the chart we just did. Because it's less than or equal to, are they connected or not connected? They're connected. So we're going to connect them. Okay. That's what I mean, whether they're connected or not. Our interval now, so that's our graph of it. We're done with that. Our graph is done. On our interval, we're still going to have 2, 3. Okay. Is it open or closed circle? Closed. So they're going to be brackets. We're done. Okay, we plug in our values. It's only one interval if it's less than or equal to sign. That's it. Our solution is done. Does that make sense? Yes. It would still be connected, strictly less than. So if we want to change up this problem, it's a good point. Let's say we get something like that, right? You're thinking of something like this, right? So let's see how that changes our solution. Let's just see how that changes our solution. Let me erase this. If it was strictly less than, do we have open or closed circles at 2 and 3? Open now. Because it's less than, is it connected or not? Still connected. Still parentheses this time. 2, 3, parentheses. Yes. We're factoring. Snowflake method on this, we're factoring. If I had to do this, what 2 numbers multiply to give you 6, adds up to give you -5. We're going to get -2 and -3, which become my 2 factors. And all I'm doing is I'm solving out the same way. If I set x minus 2 equal to 0, what would make 0? What would that make 0? 2. X plus x minus 3 would be 3 to give me 0. So we're just doing that. Yes. No, it still wouldn't. We still want the factors. We can still solve it out just as we would anything, right? You would still want to pull out the GCF unless it's a variable on the outside, like 2x, right? 2x, but any whole numbers, don't worry about it. It's not going to change it up. Yes. Let's look at it. Let's look at another problem. So that one's strictly less than, right? That was our less than symbol. Let's look at another problem like this. Now we're going to add another step to this, right? Because I want you guys to see this in a variety of different ways. So now the inequality is slightly different. We have a greater than inequality. So this is going to change the way that our solution looks. We're solving it the same way, but how we show it looks differently. Okay? So it's slightly different. Our first step for solving quadratic was to do what? Make sure everything's on the left-hand side. So we're going to do that first. So we're going to get x squared, bless you, plus, let me write that down a little bit further down. X squared plus 2x minus 3 is strictly greater than or equal to, or strictly greater than 0. And again, factor it. Can we factor it? What 2 numbers? +3 and -1. Okay, we have strictly greater than 0. We're good. So, what is my solutions to this? We have what? X is equal to -3 and 1. So this is definitely our solution. This is one of your solutions you definitely need to have. Okay. Now, let's go ahead and look at the way that we're going to write these out. Now, the graph of these is going to be done the same way. Just how we make them look is going to be different. So we're still going to have a number line with the same numbers. This is going to be at 0. Let's go -1, 2, -3, and then we're going to go to 1. So, and then we're going to have our interval. Now, so it's easier to do the graph first before you do the interval. So do we have open or closed circles on -3 and 1? Open. Why are they open? Because there's no line underneath the inequality, right? It's strictly greater than. Now with these ones, are these connected or not connected? They're not connected because we have a greater than symbol. So they're going to be going in the other directions away from each other. They're not connected. Yes. Greater than or equal to. So it would be for this symbol or this symbol. Open circle would be this one. So this would be open circle, this would be closed circle. Yeah, it could still be closed. It could still be closed. And we'll change that problem around after we're done here. Okay? So the inequality now looks a little bit differently. So now we have a solution right here for one of them, which is going to go from -infinity, comma -3, open bracket, to this other portion, which is going to go from 1, comma, infinity. And this is an and. So these are both of them. This and that are our solutions. Does that make sense? Is that a little bit more clear than what we did? Yeah? Good. Now again, Vincent's question was still valid. Well, can we still have them closed? So yeah, so if I change this around, you do not need to change this. Just look up here. Let's say let me get rid of this right here. Let me get rid of this right here. Now let's say the inequality is strictly greater than, so we have greater than symbols all the way. So now if I have greater than symbols, let me erase this as well so you guys can see it. It's pretty much graphed the same way, right? Do I have open or closed circles? Closed this time, right? They're closed this time. Are they connected or still going away? Still going away. Nothing changes on those. It's greater than or equal to or greater than symbol. Now the way that we write this one is -infinity, comma -3 with a parentheses or bracket. Bracket this time. Yes. Not connected. Yep. It's exactly that. Exactly that. Is this easy or hard? Easy. Okay, that's all I wanted you guys to see today. Let's do a couple more problems. We got about 10 minutes left. If you guys do a couple problems with me, I won't give you any homework. Is that cool? Okay, let's do that. Let's look at this one. Let's look at this one. If you guys want to try this one out, get a little ahead of me before I start this one up. My first step is to really do what? Got to bring everything over to left. It helps out so much when you do that to write out your inequalities. Okay. So if I bring everything to the left-hand side, some of you guys are a little bit ahead of me. Already got the factors. You're already starting to graph it. Perfect. This would be minus. Minus 2. Less than 0. What are my factors? Have our factors perfect. What should I do? What's my solutions? 2n, -1. So this is my solution here. We got to be able to show that how that represented on an inequality graph. Now we have a less than symbol here, so the way that the less than symbol is going to be important for us to do. Our graph for this on our number line is still going to be at -1 here, 0, 1, and 2. Open or close circles? Open. Our inequality is strictly less than. So there's no line underneath that line, so we can't bubble them in. Now, because it's less than, meaning it's going left, are they connected or not connected? What are they? Connected. So we're going to connect them on the inside. And because this is only our one solution, so our interval, we want to be able to write our interval. We only have one solution to this, right? Open bracket, -1, comma, 2, bracket. Done. Is that what you guys got? Perfect. Perfect. That's our solution. Question?
Okay. So it doesn't matter if like, okay, so you have like X, Y, it doesn't matter if it's
How you rewrote them for our X value, so you're talking about my solution here?
Yeah.
No, when you graph them on your number line, it should look correct. Right? We should have them in descending order. So this is why I always say it's good just to graph the graph first before you write the inequality. Because pretty much the number to the left will always be the number to the left-hand side. The number to the right will always be on the right-hand side. Even though in the beginning of our solution, it's backwards. Right? But when you graph it, it looks really nice when you do it. Does that answer? Yes. Not necessarily. Not necessarily. I could have rewrote it where -1, comma 2 was at first. I just, the way that I wrote out my factors, that's how I just got my solution. These are just the numbers we want to represent on the number line. So if you write them on the number line, it will look clear and it will look nice. Does that make sense? So it's not the way that we're writing it. Here, let's try out another one. Let's try out this one. My first step is to do what? Everything on the left-hand side. What are our factors? What would be my solutions? X equal to 1. Perfect. Yes. If you have a question, let me know. What's up? Okay, okay. Let's see how you graphed it. Let's see how you graphed it. Our graph on our number line here. Let's see, 1, 2, 3, 4, -4. And we're going to look at +1 here. Open or close circles. Close. Our inequality is strictly less than or equal to. So close on -4, close on 1. Because it's less than or equal to, are they connected? Yes, they're connected. My inequality, or my interval, interval is going to look how? Bracket, what? -4, comma And again, like I'm saying, if you graphed it, pretty much the left number is going to go on the left-hand side, the right number is going to go on the right-hand side. Easy enough. Okay, let's try this one out. Last one here. After we're done here, we still got like 3 more minutes. Let me kind of clear this. And do it. Try this one out for me. Oh, no, hold on. Come on. Hold on. Try that one. Just last one here. Easy lesson? Good. Not really? Shouldn't be too bad. X plus 4x minus 3. Open or close circle. Connected or not connected. My intervals is going to be negative infinity, comma, negative 4. And what? That's it. Good stuff? Okay. No homework tonight, guys.